I'm Josh. I work on the
Yeah.
spring team, and I'm his friend.
And I'm his friend. I'm Asir from Microsoft. At Microsoft, I'm on point for Java on Azure. That means everything customers and developers need to build, migrate, and scale Java apps on Azure. I'm also a Java dev. I started in 1995 with JDK1, and I've been working with Java ever since. I've been in Microsoft for 18 years, just focused on Java, Java, Java all my time, right? I'm also from India, right? You can see that. I'm from, I was born in a small village near Tirunelveli, and I grew up in Coimbatore. I was here all my teenage years and my college years, and I went to United States about 32 years ago. I finished my grad and then slowly joined the industry, started with Java, been focused on Java, and I joined Microsoft specifically to turn the thing to embrace and take it to the next level for Java. Right, so I'm very happy to be here. And with that introduction, we should start, right?
Yeah.
So we'll start with a typical architecture, right? I think this will look very familiar to most of you, right? What happens is in this diagram, you have users. They're coming in through a gateway. They get the front-end user interface. That's running in a browser, and then it interacts with the back-end REST APIs. Those APIs are powered using a database. And of course, when you connect to the database, you need to store the secrets somewhere. That's where you have the secrets management. Right? And when the users are coming in, they get authenticated and authorized. So that's the identity provider. Like all systems in production, they must be automated, they must be monitored, and everything must be secure. So how many of you are familiar with this typical architecture?
Pretty stock standard stuff, right?
Yeah,
I mean,
pretty stock standard.
okay.
All right.
Now, I think we should make it real, like connect these pictures and boxes to like an actual thing.
Yeah, so I'm going to pull up an app that looks just like that, and we're going to run through, right? So let me go.
Oh, more people are still coming. That's great.
Awesome. We should take another picture.
Oh, yeah, we should. Well, by the end of it. Okay, so if you all stick around, we're going to take one more group photo. It'll be fun.
Yeah, it'll be fun. So here it is.
Ooh,
So that's a storefront. So I'm going to make it bigger. So you can see that it's a fitness store, right? So
not for me. I don't use it at all. I'm web scale.
Right. So here is a catalog. I can look at the catalog, right? You'll see products come through. Let's say I'm going to buy some things for my daughter.
Yeah.
Right? So I'll start with a water bottle. Right? I'm adding to the cart. So the first problem.
Is that dollars or rupees?
See, I'm not logged in.
Oh, okay.
I have to log in now. So I go here and say log in. So it's connected to my Microsoft directory. So what happens here is I'm already logged in, so it authenticates right away. If I go and check, it'll show you who I am. You can see it.
That's your middle name?
That's my middle name.
Oh, that's nice. I feel like I'm learning something new about you.
Yeah, I mean, that's what the system has, right? Microsoft directory has.
No, it makes sense. That's
right.
Very smart.
So now I go here and I order the bottle. Now I can add to cart. Add to cart.
That's dollars again. That's not rupees.
Exactly. It's not rupees. It's in US dollars. You can see that. Yeah. And I go back to the catalog. I want to buy maybe a bike for my daughter. So I'll add the bike.
Nice.
Yeah.
Very, very
this
generous.
is all good. So add it. Add to cart.
My daughter's getting that photo I was talking about earlier.
Super.
Not the same. You're buying her a bike. I'm getting her a photo.
So I can now go to my cart. You will see that two items are there, and I'm going to proceed to checkout. So I'm going to put my name. Okay, you see it's my address. I changed to delivery method. Right, it's the tractor-based delivery. It's more advanced.
Okay.
And I'll continue to do the payment. It'll ask me to put in some numbers. I'm not going to put my real number.
No.
All right. Okay, some number. 348 is a good number. Of course, it has to be something valid. So I put it to 25.
So just for clarity, this is not a real credit card that we're typing in here
Correct.
live on a jumbo screen.
and record it for the YouTube as well.
Right. Yeah, yeah.
All right, my order is all ready, and I place the order. All right, there you go.
Okay.
Order
Yeah,
is
so it
placed.
works. It's not a
Yeah.
toy.
So what I did here, Josh, is I came in through the gateway.
Yeah.
I got the Node.js app on my local laptop.
We need to fix that.
Yeah, and then what happened is my Chrome browser started connecting with all the backend REST APIs like the catalog. I pulled the catalog, and I then logged in, and I added to the cart. So the cart REST API was there, and then I started placing the order. Then I placed the payment.
Right.
So all these apps were in play. Right.
Okay.
So what I'm going to do is I'm going to show a little bit more about this architecture here. So I'm going to go here and go back into the presentation mode, right? And you would see this is what I did. That's what I did.
So okay, just have some questions here. Who's using Spring Boot? Nice.
Oh, super.
Awesome. Give yourselves
That's
a
great.
round of applause.
Awesome.
I'm a fan. For the cameras that didn't see that, that was like, I think there's 2 people that said no, and those people are wrong. What about okay? So what about Python? Who's using Python for something? Yeah, that's cool. I like Python. What about .NET? Okay, good stuff too. Who's being used by JavaScript? All right, yeah, there's a good many of you as well. Okay, so that's pretty representative of this audience, this architecture here. Pretty straightforward, stock standard.
Right.
Lamentable, recommendable, commendable.
I think this is common for line of business or even a storefront. You can build many scenarios using that.
Oh wait, who's using Postgres, by the way? Postgres, good stuff.
Ah, look at that.
I love Postgres. It's big. Okay, is it the majority? Is that the majority of the audience? Did we see?
Why don't you raise your hand one more time for Postgres? It is.
Yeah.
It is.
Who's using a SQL database? Okay. Who's using MySQL or MariaDB? That's the minority by a lot. Okay. What about Oracle? Oracle's DB. Okay, good number, but I think Postgres still has it. What about a SQL Server? Cool. I think Postgres is both the majority and the plurality. That's neat.
Yeah.
Okay, good stuff.
Absolutely.
What's the alternative? Feels like a good many people raise their hands for SQL databases, but not all of them are Postgres.
Maybe MongoDB is the other alternative.
Well, that's not a SQL database.
It's not a SQL.
Who's using MongoDB?
Oh, that's quite a good number.
Yeah, good
man.
number of people. Yeah, good stuff. Okay, just wondering. I just wonder this stuff because this is as goes Bangalore, an electronic city, so goes the world. Like if it works here, it works everywhere.
All right. Let's take a look at this code base, right?
Okay.
So I'm going to shift to my VS Code here.
Okay. Another question. Who's using Visual Studio Code? Hey.
Wow, that's fantastic.
Let's call that like 30%, right? That feels about right. A lot of people.
Maybe more than 30%.
Yeah. Okay. Eclipse. Wow. Okay. Like 5, 10 people out of a room full of more than 100. What about IntelliJ? IDEA. Okay. Okay. All right. Well, that's still very much the majority, very clearly. But there's no bad choices. I'm just wondering. Okay. I'm just wondering. I don't care. Just whatever.
Right. So all the apps are here. So you can see the catalog app is here, the identity app is here, order is here, payment here, shopping here.
So these are like microservices?
These are all microservice. They are small apps. Right?
Yeah.
Let's take a look at this code base here. So if you look at this, so then I go into settings and Gradle properties, you can see it's Spring Boot 3.0, right? And if I go into the code base, you would see that the product controller is a simple REST API controller. It gets me all the catalog and then specific information about a product. Right.
So pretty stock standard stuff. You've got a controller delegating to a service.
Mm-hmm.
Yeah. Okay. Fantastic.
That's it. So now if I go into the Node.js app, the Node.js app is right here. So let me close the Node.js app. The catalog is here. The shopping is the Node.js app. If I go in here, if I click on this, so this is your Node.js app. That's it, right? And the remaining, there are some more Java apps, Spring apps, plus C#. All of those code are right here.
Cool.
Right. So one thing, we're not using anything fancy here.
No, just this pretty representative of like every app I've seen, like 90% of the apps I've seen in the last 20 years, like pretty standard stuff, right?
Yeah. Pretty
Okay.
Pretty standard stuff. So I go back here and I put my stuff here, right?
Woohoo. Uh-oh, Mac. That's not. Oh, okay. There you go. You did it.
It
Good
came
stuff.
through, right?
Thought we had a slide malfunction.
So this is from Uber. They published it in 2020, right?
Yeah.
What they said is for all their operations, it receives only about 300,000 requests per second.
300,000 requests per second for people using the service to get cars and all that stuff. By the way, I haven't been here since before the pandemic. I've noticed that Uber is now very usable here. Like it's everywhere. I hit the button like a minute later, I get in a car. It's amazing. Is that new? Is it just been like, it's really good. I haven't been here since 2019. It's picked up like so useful now. Okay, good. So that's 2020.
Right. And then let's go to 2021.
Oh yeah. So this is how many of you know Alibaba? They're an e-commerce chain, e-commerce website in China in the greater region, and they have 11/11. 11/11 is Singles Day, right? It's like how we have Valentine's Day, kind of in some place. This is the opposite. This is celebrating you're just being all alone, so you go shopping, right? It's a kind of a it's not like a real holiday. Cyber Monday, that kind of thing, right? It's an online e-tailer holiday. They have the same thing, right? And Alibaba. I first heard about Alibaba back in 2012 when I learned that they made more money in 24 hours than Amazon and eBay combined had made the same year at Cyber Monday, right? And Black Friday, right? The sales from those two websites, two of the biggest in the world, were not even taken together. They weren't what Alibaba was doing, right? Which is a huge scale. So what is that number there? What does it say?
533,000 requests per second.
Right? You can barely see it. It's almost impossible. But
are you all able to read it?
Not really. It's
okay. So let's call it out. It's here.
Yeah.
53300 requests per second.
So 533,000 requests per second. For one of the largest portals on the internet,
correct,
period, ever.
Yep.
Okay. Doing pretty good.
Doing pretty good. So now it's the coffee shop.
So the question is, can we do better? And if so, how long do you think it should take?
As long as you can take to make chai.
Right. How long does that take, roughly?
25, 30 minutes.
Good chai, not like
good chai. Like if you slow brew it. I'm not talking about the dip chai. You really start with some milk and water, slow boil the tea, and then add some ginger and cardamom, and slow boil it until it really makes the chai, and then finally you mix the sugar. You don't mix the sugar before, right? Then they start charring, right? And that can take up to 30 minutes. But if you're making for a little bit of a party, right now it's for a party, you can see the size of the chatti there. Right? It's huge. Chatti, you all understand chatti. That's the name for utensil.
Right.
So it'll take probably 30, 35 minutes, and you'll have the chai ready to go.
And by the way, I love that photo because look at that little girl. She's looking at the chai.
She's mesmerized.
She's like, that's what I want. Get out of my way. Yeah. So, and I also, just between you and me, like just so we can do our retro on this thing, this was a mistake coming on stage without some chai. I am very thirsty. Next time. We'll do that better.
We should have ordered the chai so they deliver right at the end of the talk.
Yeah, for the whole audience. Like
the whole audience.
Like Oprah. Everybody look under your seat. A cup of chai.
A cup of chai is sitting right for you, right? That'll be the fantastic
next
one.
time.
It's always the next time.
Okay, so about 30 minutes. So can we do better? And if so, how long will it take? I think we have ourselves a challenge here.
Correct.
So let's do that.
Let's do that, right? So what we're going to do here is, you saw in that architecture there are several REST API, right? Now, as a user of a fitness store or any storefront or any line of business application, right, you'll first hit the catalog. You'll see the catalog. So what we'll do is we'll take the catalog REST API controller and apply some pressure on it, right? A lot of pressure on it, right? But we'll start. So here, I have the catalog REST APIs right here, right? I'm only running one instance of it, right? One instance, it got 2 code and 2 gigabytes of RAM. 2 gigabytes of RAM.
Okay, one instance of the app
Yeah.
with 2 gigabytes of RAM, which is way more than you need.
Correct.
That's almost enough to run Slack, right? That's a lot of RAM.
Yeah.
Okay, so good. So 2 gig. Okay, good.
So now if I look at the configuration, there isn't much. There's nothing else, right? I'm not setting anything, just taking all the defaults, right? And then I have this database. I have about 2 cores running the database. You can see the 2 cores of that.
2 cores. Where do you see that?
In the configuration file.
Oh, so on the right-hand column, that little blue link there,
It's
general
2 cores.
purpose, D2, DS,
2 cores.
D4, 2 cores, 8 gigs of RAM. Okay, good.
That's
Postgres.
That's what you get default when you create a Postgres database, right? Unless you set something up, right?
And we're using Microsoft Azure.
Yeah, we're using Microsoft. So I'm going to run this. So let's start the run. I'm going to use the Azure load tester to place some pressure on the system, right? So today it is 04, 28, 2023. It's 3:10.
1528. Yep.
3:10 p.m. Right? Let's do that. So I'm starting the run. So it's going to start. Right? So it's going to place some pressure right now. So it is getting started. Right?
So what is it doing?
So we have a JMeter. This JMeter, what we have configured is a curl. It's going to start applying pressure on the REST API. It's going to call the REST API. It's going to call okay, give me all the products, and then go for each of those products and say, hey, give me the details of this product, which is what you do if you're showcasing a catalog, right?
Yeah.
It's going to place a lot of pressure on this, right? Now, while this gets started, maybe we should look at the previous run, right?
Okay.
That way, we'll get an idea of what exactly happened. Right? So here is the previous run. So if you look at this, right, you can see that it ran, and the response time was 89 milliseconds. And you can see the throughput was about 2,700 requests per second. So what is 2,700? If you do the calculation, multiply by 60, another 60, another 24, it'll give you 233K requests per day. Right? That's a good load, and you can see the response.
That's just one instance, or how many instances?
Just one app instance, 2 cores, and 2 gigabytes of RAM. Nothing more than that.
Fair.
Right?
Yeah.
Right? And you can see the other important thing is because we're only running one instance, there's not much errors as well, 0 errors. And you can also see the request went to get the running shoes, red pants, weights, yoga mat, basketball. You can see all those requests have happened, right? So it's simply one, right? So if we were to look a little bit deeper into this, right? So here, what you would see is, right, you would see that there's about so many pending connections here. So let me give one more minute here and see if the other one started, right? I think it's here. This is the test. I'll go back to the run. It is executing. It's still provisioning. So let me leave it behind and come back to here.
Yeah.
Right. So here you would see that there are a few pending connections as well. So you can see these are pending connections.
So what does pending connections mean? Like it's trying to connect to the database and it can't, or what?
It can't, because what happens is, if you know Hickory database driver, right? Hickory driver for Spring Data JPA, there's a default number of connections in the connection flow. How many of you know what's the default number? 10. So you see the 10 right here. That's the max it can go up to.
Okay, so it's making one request per thread.
Correct.
Okay, yeah, one transaction. So
because we're not using anything reactive here.
Right. Well, oh yeah, that's a good point. This is achingly unoptimized. It's using JPA. It's not using Loom, which doesn't even exist yet. It'll be out in a few months. It's not using reactive programming. Not using GraalVM. This is just run-of-the-mill, like
Typical. That's what
stuff.
they find, right? They don't find anything more than this.
Yeah,
right?
yeah.
Typically.
And it's default settings, nothing, no fine-tuning, nothing like that.
Correct.
Okay.
So the next one is I'm going to make some changes here. The way I'm going to make some changes is I'm going to add one more instance.
Okay.
Right? So
how do you do that?
I added one more instance right there. You can see running app instance is 2.
How did you do that?
I set it up earlier because it take a couple of minutes.
Oh, okay. So you can modify. So this is running app instances
Two.
2 out of 2. Okay, fantastic. Good.
Two instances. And if I look at the configuration here, I don't have any fancy configuration, right? It's just nothing fancy. Let's wait until it refreshes here. And the network is slightly slower. Oh, okay, nothing fancy here. Yeah, I can reveal all values, nothing fancy here.
Yeah, just
right?
regular memory.
Yeah, that's it. Yeah. So, but what I did is because there was a lot of pending connections. The app was trying to connect. I added more power to the database. So I put it as 16 cores. You can see that
16 cores for this Postgres database.
for the Postgres.
Okay,
database.
so that means, but I thought we only had 10. Oh, but we've got two. We've got two instances
Two
now.
app instances.
So in theory, you're going to be 4 short,
For sure.
possibly. Yeah. Okay.
Yeah. And I also enable more, because when you buy the 16 cores, it also comes with a max connection instance of 500 on the back end.
Yeah. Okay.
So that way we can, right?
Good.
So now you can see if I go into the database and do a max connection, right? It will tell you by default it is
5,000.
5,000.
Whoa.
It's 5,000.
So you can have 5,000 different database connections to that single Postgres instance.
Single Postgres instance. Right? That's pretty huge.
Yeah. Great. Okay.
So then I try to run now. It's a different run. What happens here is you get roughly about 6,700 requests per second.
What was it before? 2,000.
2,700.
So we're now at 6,000, and I'm an American. We're not great with the numbers, but is that 4,000 more ish?
It doubles, right? Almost doubles. So you get about 500,000 requests per day, right? It doubles up.
Okay, 500,000 is nothing to sneeze at. That's certainly fine.
It's certainly fine. And also you would see the response time has improved a little. And you can see there are little errors here. One error.
Error?
One error.
One error.
One error.
Okay.
Out
Yeah.
of this massive load. The massive load is pretty high here.
There's another error.
There's
The
another
water
error.
just fell.
The water just fell. Right. So
Okay, so we've got an application. We've got a lot of load going into it right now. That's fine. What can we do to make it better?
yeah, I think so we should look at what happened, right? So
Right.
this is where we are going to zoom into that metrics panel.
Okay.
And what you would see is, so this is a good one to see, right? So you would see that the number of connections is still at 10, but the pending connections are a lot. It's about 60 pending connections are there.
60 pending. I thought we just increased the database connection pool on the back end.
But the client side is still only 2 app instances.
Oh, okay. So the database can handle as much as the web apps can throw at it, but there's not enough web app to go around.
There's not enough web apps.
Okay, so how many app instances can we allocate?
We can allocate more. So this is what we're going to do next, right? We're going to increase a little bit more. So let me go into the next one. So now, look at the number of app instances running.
So now you've got 130
130
app instances, which is, some really good. You could run Slack. That's enough RAM to do
It's
that.
a good amount of power.
Yeah.
A lot of power, right?
A lot of power.
Right. So with this power also, we should look at what we're going to do with the configuration.
Okay, so now you can use environment variables. Who knows this about Spring Boot? You can override the properties with environment variables. So like server.port, if you wanted to override that outside of the Java program, you can just say export server underscore port, capital letters, equals whatever, 9090, and it overrides the server.port property. Right? So we're going to do that here. We're not going to reload the code. We're just going to change the property.
We're not going to change the code or redeploy or just change the property.
Okay.
We just put 35.
So Spring data source Hikari maximum pool equals 35, not 10, but 35.
35.
Okay, so what does that give us?
Right. The reason we put 35 is if you multiply 35 by 130,
Right.
that's 4,900 connections.
Why 130?
I have 130 app instances.
Oh, right. Okay. So it's just under 5,000 connections.
Correct. Because I get 5,000 connections at the back end. So we just reverse engineered 5,000 divided by 130 is going to be 35. So that's what we set it up.
So now we can create as many connections on the front end as the back end will handle. They're basically in sync. This is slightly less than the back end will handle.
But since I'm adding 130,
Right.
the pressure will be on the Postgres database.
Right. Which is good. Saturated it.
It's saturated. So what I do now is I increase the number of cores. Okay.
How many cores?
64.
Okay, so we went from 2 what was the second one?
2 to 16 to now 64.
Okay, a lot more cores. Beefy. Okay, good. And we're just finessing numbers on a website here. We're not actually like redeploying Postgres ourselves or anything like that. Okay, good.
Right.
Good. I don't want the fitness URL. Okay.
So here, if I look at the max connection, right, it's same 5,000. Right now, here I didn't have to set it because when you get 64 cores, by default it is 5,000.
Right.
Right? I don't have to make any changes here.
Okay.
Right. So then we run the test. Oh, here's the description of how you can see that if when you buy 64, it gives you 5,000 connections.
Okay, so wait, this is hard to see in the screen. So you're saying if we got the 64 core distribution of Postgres, the service, it has 256 gigs of RAM, and then 5,000 max connections and 4,997 max user connections. Correct. So I guess the other ones are for maintenance purposes. Okay, good. Correct. So you can't really see it. That's really a shame. The aspect ratios.
Yeah.
Very weird.
I also. Are you able to read?
No, but
no.
They're
able to read. Okay.
I don't know. Just take our word for it. Big numbers.
Big numbers.
Big numbers.
Big numbers. Right.
More than I can count on my fingers.
So now I run the test.
Okay.
Right? Now if you look at the number 45, I have 45 users pounding with lots and lots of thread.
Okay.
I get 95 milliseconds, and you can see the throughput is 82,000.
So we're getting now 82,000 requests a second.
Correct.
Okay, sounds good, but
that's not enough yet, right?
Because no, we're not even close to 500,000.
Yeah, we're not even close to 5,000. The reason that we are looking at this here is, we have 130 app instances running, and we have a database that's 64 cores, and we are only getting 82, right? So there is something wrong there. We should be getting a lot more.
Yeah.
Right? And that's where we need to pound on. Right?
So how do we increase that?
So this is where we need to go a little more deeper, right? So first of all, I'm going to increase the number of app instances.
Okay, how many? Oh, 495?
Yeah.
Yeesh. Okay, so this is like, we're spending some serious money here.
A lot of money.
Yeah, but the results will speak for themselves.
Yes.
Microsoft has money, right? They can afford this, right?
They can afford this. Yeah.
Okay, just making sure. Okay, good. So, good. 495 instances.
Yeah. And
is
it's 2 cores and
okay.
2 gigabytes of RAM. So if you multiply, it's about 990 cores.
Woo!
Close to 1,000 cores.
Yeah.
Very, very close to 1,000 cores, right? So here, if I look at the variables, right? So we are setting up some values here.
Yes, sir.
So when the write happens, certainly there will be a different set of characteristics, and you will have to take that into account as you scale out and pound on the database.
The question is, does reading versus does writing change the numbers? Yeah, of course, but
it will. But for catalog, if you take catalog, right? Catalog is mostly read, right? Whereas if you're working on the order controller, that will be read and write.
Mm-hmm. Oh, okay. Horizontal distribution. Yeah. There's always going to be.
Yeah, I think you have to take all of those into consideration as you allocate resources.
Right.
So in this case, we are applying the pressure on the catalog. If I apply the same pressure on order, it will be slightly different. You have to think through many other aspects of it.
Yeah.
Right. So what we are going to do now is we're going to place the load right here, right? And let's see what happens on the load, right? So we have about 495, but I want to point out that I reduced the connection to 4.
Okay, that's going to be a problem.
Yeah, because what happens is now that I have 495 instances, they're going to open a lot of connections.
I see, okay.
I have a max only 5,000.
Okay.
Right?
Right.
Now, one of the other important thing is, this is where I'm also going to make some code changes.
Finally. Okay, good. Let's go see some code.
So we're going to make some code changes here. So I'm going to go to the code now. Let me open this guy.
Because I'm thinking about this. I'm like, well, this is a read-only thing. I think our friend in the audience who just asked that question was like leading towards something kind of interesting.
Yeah.
What are we going to do in the code?
So I'm going to bring in the caffeine cache.
Okay. So anybody who knows what the caffeine cache manager implementation is? Who knows about the Spring Cache Manager abstraction? All right, so Spring has this interface called Cache Manager, of which there are a number of implementations supporting things like Redis, Hazelcast, Apache Geode, Caffeine, Cache. I mean, just any number of different technology implementations, plus the JCache spec, right? So those are just they're a great way to memoize, right? You can remember the result of a computation and then return that from a cache rather than recomputing it. This is ideal for the kind of thing we're doing here, which is reading not particularly volatile data from a catalog. Okay.
Right. So we are bringing in cache. So you would see
Let's make the font as big as possible.
Big as possible. Right. But it gets skewed on that diagram. Yeah.
Okay.
Right. Yeah.
Can you all read that a little bit?
You can read it? Awesome. So I'll also bring one other, right? So the product, where is that file? The repository, right? You would, not the repository, it's the response where you would see the cacheable being marked.
Okay.
Yeah.
So we're using cacheable elsewhere as well. Okay, good.
Right here.
So
see?
Yeah. So getting the product, caching it, getting the product by ID, caching it, got a key for the ID.
Right.
All right, good stuff.
So this is one reason I don't have to go back to the database all the time, right? That's why 4 times 495 is about 2,000. It's enough, right? So one of the other things I'm going to do here is, I'll go back to here. One of the things I'm going to do is I'm going to now reduce the database size. I'm going to bring it from 64 to 16.
Okay.
Right? With, of course, 5,000 connections, right? With that, we can actually start the actual runs, right? This is also max connection. If I see, you will see that it's 5,000, right? Now I can start the thing. Now, one of the things now we're going to do is we're going to pound for the 100 billion.
Okay, let's do it.
100 billion requests, right?
Right.
So I have to start 10 test engines in parallel.
Well, let's see. I mean, you've got the cloud.
I got the cloud.
Okay.
So since I can't start 10 in front of all of you, I asked one of my colleagues to start while we are talking. So they already started, right? So the engine is running at this point. So let's take a look, right? Boom. All right. So you would see it is,
Oh, that's. So what's happening? It's 1 million requests a second.
coming in. Yes.
You can barely. Oh, that's hard to see, unfortunately.
Let me do a plus right now.
Yeah.
Right. Command plus.
Bigger.
Bigger.
More. Okay, there you go.
Can you see
You can
this?
see that right here.
Yeah.
1.5 million requests per second. So it's a little bit more than a million requests per
Million requests per second.
across all the instances.
So this is where, when we were testing with Azure load testing, we actually broke it.
We did. Yeah. So they have a cloud thing, and the issue is that our latency, our response time is too low.
Our response time became, because we are caching and we are going to the database as needed, the response time was very slow, very low, like of the order of like 20 or 15, right? At that point, because the response is coming back so fast, we broke the load test. And what we had to do is we had to literally create 10 load test configurations and run them in parallel. The other thing we did is, we showed you lots of metrics before, but we're no longer showing the metrics here.
No, there's a reason. We broke that as well.
Because what happens is, if you're running at this load, right, imagine the amount of logs and metrics and tracing info generated. Right? The first thing that will happen is, if your organization has placed a cap on how much data you can collect, it's going to say, stop it, stop it, stop it. It's no longer a sync. It's coming back to you and say, stop it, stop it, stop it now. Now, when you're in this scale, you don't need all the data. All you have to do is start sampling them at 1%.
Yeah. And for Spring, there's a property there called the sampler probability. Yeah. You can say, I just want to sample 0.01, for example, right. 0.
Also, for the logs, what you can do is you can go to the configuration and start configuring to the lower level,
right?
Not spend too much log, because otherwise it's going to hit a lot on your credit card.
Yeah, which is not good. Okay, Good. So we got our scale.
Yeah.
Huge numbers. Good
It's
numbers.
huge numbers. So you
Not-
can see it running.
Right. And we didn't do anything. We didn't do anything smart with the code here. This is just regular, like,
Yeah.
taking an app to scale. Obviously, the power of the cloud, unmatched. How are we doing on time?
We're doing very good on time. So
Okay, let's-
one of the things that we were doing, as you said, we didn't do anything on the back end. All we were doing is we were configuring it differently, and we just added the cache code into the Spring Boot, and we were choosing different databases and the connection parameters. That's it. Now, in your code, right, when you're writing your own app code, you probably have some business logic. So you also have to focus on that in addition to what we are showing right here. Right? Now, I'm going to show you one of our previous runs. You can see this run, but I'm going to show one of your previous runs to you. So here is one that we ran a little while ago sitting in the speaker room.
Right.
It's now at 2 o'clock. And you can see how it went up from zero, almost 200 to million, and then we stopped the load. Right? And last week, I ran a similar one. And you can see this is 417. You see it goes from 0 to 1.38 million requests per second. And then we stopped the engine and it came back down, right? Now, one of the things we have done here is I actually set up auto scale.
Right. Autoscalers are good.
All right, so I started from 0 there. I had like 2 or 3 instances up and running and auto scale. And as the load came in, it started provisioning as fast as it can. And it gets to all the way to the top. And then it slowly came down. Right? So that's
Good
That's
numbers.
right. You actually don't pay anything for when you're here, but you pay only for what you use right here.
Right.
And that way you can save some money, right? Similarly, when you're doing the load testing as well, one of the things that I was able to benefit is I didn't create a lot of virtual machines to run the load test. I simply configured it. So it'll automatically provision the engine just for it, and it'll run for 30 minutes and stops, and it deprovisions everything. So I only have to pay for the 30 minutes, right? That
Yeah.
way it's a little bit easier, right? So this is the configuration. Let me get out of here and we go back to our tech here, right? So we said, right,
Chai's done.
size done,
Less than 30 minutes,
less than 30 minutes.
which is good. So now, I mean, was this the most cost-effective way to get to scale? Yeah, actually. Compared to like rewriting the code,
Yeah.
it's a far sight easier to do that and scale up, right? What's the big holiday? Is it Diwali? Like, what's the biggest like holiday
I think
here?
it's the 3-4 weeks before Diwali, right? That's when the load comes in. Is that correct?
Right.
Are there any other days? Is that Pongal? Pongal too, right? So that depends on the state, right? Pongal, south is Pongal. In north, probably a different celebration. But definitely the 3-4 weeks before Diwali is like boom, boom. But do you all have something like Singles Day in India? What is it? So there's something.
What is it called? Big Billion Day. Billion Day.
So Amazon runs similar to Singles Day here. Sorry, I've been out of India for a long time, but I started.
We're learning.
We're
learning on the fly. Good stuff.
Good
Okay.
stuff, right? So let's just summarize what we have done, right? So we started with one app instance, 2 cores and 2 gigabytes RAM with 2 cores of the database. And then we upped it to 2 app instances, and we increased to 16 cores, right? And then we went to 130 app instances with 64 weak cores, and we set the connection pool to be 70, right? And then we went to 500 app instances, and that's where we brought in caffeine cache, and we brought it down to 16,
Okay.
right? So that's about 113 billion requests per day. If you compute the numbers, 1.38 million requests per second is about 113 billion requests.
Good stuff.
Good stuff, right? So now,
Contextualize. You can't really appreciate how big that is
yeah,
without like a frame of reference, right?
yeah,
So we mentioned Uber. We mentioned Alibaba.
Alibaba, yeah.
Yeah. Okay.
So this is where you have to put some perspective, right?
Yeah. People don't appreciate just when you go to like first time I went to Agra, like I became food for the bugs, but also I realized just how small I was compared to that beautiful, beautiful Taj Mahal. And then there, yeah, exactly.
Yeah. So now you can see, with people, you can see the perspective, right?
Yeah.
how big that is. So let's take a look at how that looks for Alibaba, right? So in the singles day, it was 583, not 533. We couldn't read it right? 583 requests,
Okay.
which is about 58 billion requests per day.
Right.
Now, what we have done, we have deployed to one service, and I'm only using 25% of the available capacity. I was able to go up to 1.3 million requests per second with 113 billion requests per day.
113 compared to 50 something.
8 billion.
58 billion. Okay, so double basically.
Yeah, double.
Yeah.
Double, right? So let's also look at what Uber says, right? Uber is 300,000 requests per second, which translates to 26 billion requests per second, right? And that's like 1/4.
Yeah, really good.
Yeah, we got that, right? So,
all right. Now there are how would you build this? You could use Kubernetes. Have you ever seen this page here, my friends? This is the CNCF landscape page, right? It is actually a fractal. So if you zoom in, there's more projects, right? Just you could do this. I'm not saying there's anything necessarily wrong with that, but some of us just want to get to production and go home on time. And I would argue that this is probably not the best way for a lot of use cases. You know, maybe for some, certainly, but if you just want to get a stock standard Spring app into production, what's the best way forward? And like, what is it like to use, you know, Kubernetes and all that stuff, right? Next slide.
yeah.
Like, it's painful sometimes, right? Like, it's not good. It could be worse, right? But it's also not great if you're just trying to get to production. So, is there an easier way forward? I think there is.
There's an easier way, a simpler way, like the way we were doing it today, right? So there's a simpler way, right? So Microsoft and VMware, we joined together. So
the Spring team at VMware.
Spring team at VMware and the cloud team at Microsoft, we joined together and we built a service. It's called Azure Spring Apps. This way, it's a fully managed, you focus on building and running your apps that run your business without worrying about all the networking underneath, mounting YAMLs and JSON and infra, host nodes and patching. You don't have to do any of those things, right? And once deployed, you can easily monitor app performance. You can rapidly improve, just like the way we were improving today, right? And it's well integrated, and it was jointly built by Microsoft. I'll give you a little more details there, right? It is built on Kubernetes, so you can also build like the way we did it. Right? The magic is on top of Kubernetes. It is built on Kubernetes, but the exciting part is you get the power of Kubernetes, but you don't have to really worry about learning or managing it. So the service itself looks like that central box here. Each service has 2 instances of the Kubernetes cluster. Each service has 2 in the cluster, and it's completely abstracted away. You don't have to worry. And you can see the service runtime is running on the left-hand side, and your apps are running on the right-hand side. Your apps can talk to any services, whether it's on-prem or in the cloud or any external services. You can actually get all your logs, metrics using any tools and platform of your choice. You can secure using machine identity or end-user identity. You can automate using any tools and platform of your choice. You can use any of your tools, whether it's IntelliJ or VS Code, Maven, Gradle. You can deploy all of those things, right? Now, if I remove all the details there, you can see Microsoft and VMware will take care of all those details right there.
Yeah. Do you want to talk about support?
Oh, support. Yeah, let's go straight to support. One thing I want to show you. So it's pretty easy. You just create the service, create the app, and you deploy. That's all. So it's the last thing that you will keep on doing it.
It's hard to see it, but there's a command line called AZ, which is the Microsoft Azure command line. There's a sub-command called Spring. So you're saying AZ space Spring space create, and then giving it a name and the SKU and whatever. And then AZ Spring app create the name, and then you deploy. AZ Spring app deploy. So 3 lines gets you an app that's up in the cloud,
absolutely
scalable and ready to go in that console.
Correct. And once your apps are up, you can connect with any of the services. And you can also use your existing libraries if you're interacting with existing systems, right? Now, to bring them together, if you're a developer, you can build and scale workloads. If you're an ops team, it becomes the home for distributed workloads in your team. And if you're an exec, certainly you can, you have all the headroom to grow, just like the way we showed you how to grow today, right? Yep. And it's fully supported by Microsoft and VMware, and lots of customers are using it, right? Big names. And they're all deploying mission-critical applications, right? And they get auto-scaling, app management, auto-patching, ease of monitoring, and many more rich platform features.
So about the money, like some of those customers are, you might have noticed some of them are, they've got money. They could have built their own if they wanted to. They could do whatever they wanted, and they still chose this because it just gets them there faster, right?
Production faster.
Yeah.
Production
Viable,
faster,
safe.
they can debug, they can do all kinds of things very fast, right?
Yep.
And the top of the line is the enterprise, and that's what we use today, right? In enterprise, it gets you even more productivity. It gets you to production even faster because it comes with lots and lots of powerful features that Tanzu has, right? And many of these things we touched today. And you can deploy any Spring apps or any polyglot application. In the center, you see VMware Tanzu build service. That's the one that detects the code and builds the OCI compliant container images, and then that gets deployed into Kubernetes, right?
Good stuff.
These are all good stuff. Once deployed, there's also a fully managed Spring Cloud Gateway. You can route all your app requests, and you can apply cross-cutting considerations as well through the gateway. And it also gives you 99.95 SLA. So this is where we get the support as well. So why don't you talk about the support?
Well, yeah, we have this VMware Spring Runtime. That's a part of the package. The VMware Spring Runtime is something you could buy separately, but it just comes with this, right? And it in turn implies support for like all these components. Like if you're using anything in Spring, there's support there, and it's from the Spring team. We are the people that work on the Spring team. We are the people that can contribute patches and fixes for Spring. So if there's an issue, you're coming to the right people, right? We're the only ones who can actually.
So they don't have to open a ticket on the open source base. You can just open a ticket like a support where you get entitled, right?
Yep.
So they will get back to you within the SLA, right? That gets you a lot. Now, you probably also want to explain this one. This is also very important.
Oh yeah. So this is the other thing. Things are moving really quickly these days. Java is moving every 6 months. Spring Boot every 6 months, and so the timelines for support have shortened on the open source stuff by using the VMware Spring Runtime support. This has also been you have a more advantageous timeline for support, right?
Yeah, the LO is the one that gives you the commercial support. That way, you can move at your own pace. He has a question.
So you mean to say you're providing a Spring patches? So you want us to deploy without Spring jars?
No, we're not providing Spring. This is just regular Spring.
Yeah, Spring bar. But when you package and deploy the application, like if I take a case of a Maven, right? It bundles with all the Spring jars and gets deployed. So do you want to deploy with that or without the jars we can deploy?
Just regular Spring Boot jar. Just take that, Maven Spring Boot.
Okay.
Build or whatever. Gradle build. The jar that you get from a regular Spring Boot app, you take that to Azure.
Yeah. Just toss over your jars. That's all you need to do.
There's no special libraries. There's no it's all the same exact thing. Nothing has changed.
Anything that runs on your local machine will run.
Okay, I agree. Okay, that's fine. So moving on to the next question, have you done in order to scale to the 150 million requests, right? So have you done anything specific to the Spring to process those requests, or is it only Azure which is taking care of it?
So we could have taken the route of implementing reactive, right? We could have done all the Netty, all those things we have done. But today, because most of the apps that are existing apps don't have all those facilities, and you're asked to scale. So that's what we did today.
Okay.
Right? Certainly, you can.
So there is a Spring Cloud Gateway instance before the web service.
Right.
That's just a regular Spring Cloud Gateway instance deployed on a VM on Azure, and that's forwarding the requests to our backend API, which is just a regular Spring Boot app.
Okay.
Nothing special. And like he just said, we didn't do anything. This is just a regular stock standard app. There's nothing. The source code is there. You can download the source code. It's just regular Spring Boot.
Yeah. Could you able to share the GitHub link?
Sure. We can share that. Yeah.
You want to bring it up now, or do we have it available?
We have it open. So let me show the thing. So I have to exit the thing here. Where is my searching for my thing? So it's right here. ak.ms.ms/fitness store. It's one of those stock applications. Nothing more.
Here, can I borrow this? Let me
Yeah.
see. Do you have a text editor or something?
There should be a text editor.
see, accessibility, zoom, zoom, and then use keyboard shortcuts to zoom. Okay, good. So, whoops. Use trackpad gestures.
Yeah.
Okay.
So perhaps if your others have questions, you can also ask. Okay, there's a second question. We are using the Tanzu packs. Correct.
Here's the URL.
Here's the URL. There is. Wow,
Yeah.
that's amazing.
Yeah.
So it's a star. It came from the Spring Cloud team, right? It's nothing specific from Microsoft. So
Zero samples.
Yeah.
Acme Fitness Store. Open source. Forks from the original Spring Cloud Services example.
Okay. I do want to go back to the slide. So if you want to, yeah. So let's go back here. Right. So we showed you this one. So you have the entitlement to the support, right? That's one. You can get started right away. So it's pretty simple. You just scan that and you can deploy it right away, right?
And there's free credits and stuff.
Oh yeah, we have free credits. It gets you. You can get a free Azure subscription, right? That's also available, free subscription, and we also give you like 100 hours for free. You can also use it. So that's also available, right? And we also want to leave our contacts here, right?
Oh yeah. Should you have questions, comments, feedback, whatever, don't hesitate to find us on the internet. It's fine.
Previous slide. Here it is.
Oh yeah. Take a photo.
Yeah. So this will take you to a page where you can deploy your first app, right? And you can do the scaling that we did today as well.
Thank you, everybody, by the way.
Thank you, everybody.